So in today's objective, we're going to focus on simplifying negative roots. So in order to do that, let's talk about what squaring actually is. So if I am squaring a number, it's just repeated multiplication of the same number. So for example, 2 times 2, I'm squaring it, and so it's 2 times, or 2 squared, which is 4. Right? This also works with negative numbers. So I can have negative 2 times negative 2, which is like negative 2 squared. And we know that a negative times a negative gives me, again, a positive 4. Now, to undo the square, I take the square root. And I take the square root. The square root of 4 is 2. The square root of 4 is 2. So really, I'm only ever getting a positive number. If we're being really accurate, we would say that the square root of 4 is plus or minus 2, because we just showed that a positive times a positive gives us our positive 4, or our negative times a negative also gives us a positive 4. So a key point here to remember is that to undo a square, you take the square roots. Which is what we did here. And we can only take the square root of a positive number because whether we're multiplying positives or negatives, our answer is always positive. Right, so another key point. Right? We only take the square root of a positive because we only get positive numbers when we square something. So even using our calculator, we can see that when we take the square root of a negative, so if I say square root of negative 16, my calculator tells me negative 16. It doesn't work. The square root of negative 16 isn't negative 16. Right? So this calculator doesn't know what to do. If you type it into your Solar calculator or graphing calculator, you'll get an error. So the square root of negative 16, and they say domain error. Or some calculators might say DNE, stands for does not exist. Right? We can't do it. Because the only way to get a negative 16 is by multiplying negative 4 times positive 4, or 4 times negative 4, which isn't really squaring. Square root is undoing repeated multiplication. This isn't repeated. This number is different from this number. Here we have the same number, the same number, the same number, the same number. Here we have different numbers. So we cannot take the square root of a negative. Except a bunch of math guys, some mathematicians said, well, we know that mathematically we can't do it, but if we get rid of that negative, now we can. So let's just get rid of the negative. So mathematicians just created a way to solve unsolvable radicals. And since mathematicians have great senses of humor, they decided to call that imaginary numbers. So they said, okay, well in real life we can't do this, but in imagination land we can. So we're going to have imaginary numbers, and now we can take the square root of a negative. And we represent an imaginary number with a kind of cursive I. And this lets us simplify. So let's see an example of what an imaginary number looks like. So for number 1, we want to simplify the square root of negative 24. So again, in the real world, we put this in our calculator, this is an error, but in mathematicians' imaginary world with our imaginary numbers, we can do this. All right, the first step is simplify your radical as usual. So that's following our steps. So I factor using a factor tree. I know that this is 6 times 4. 6 is 2 times 3, which are both primes. 4 is 2 times 2, which are both primes. I rewrite my radical with my negative, a 2, a 3, a 2, a 2. I check my index, which is the hidden 2, so I know that I want to look for groups of 2. This negative is kind of by itself. So really I have a group of 2, and then these other things are left over. So I'm going to pull out my 2 in front, and then inside I have my 3 times 2, and I have this imaginary. When I have this negative, I'm going to pull it out, because I know that it's a problem if it's inside, so by getting rid of it, I get rid of the problem. But to let everyone know that I had a problem originally, I just draw a little cursive I to let everyone know, hey, this was negative, but we don't care. We're going to imagine that it was regular. So then I get 2I radical 6. So really my second step is simplify as usual. The second step is pull out negative and replace with your little cursive I in front of your radical. And that's it. That's the only thing we do differently. So let's do another example where we can practice using our imaginary numbers. Number 2, if I have the square root of negative 28, I simplify as usual. Factor 7 and 4. 4 is 2 and 2. This is prime, prime, and prime. I have the square root of a negative, a 7, a 2, and a 2. My index is a hidden 2, so that means I want to find pairs of 2. So my 2 comes out. My negative also needs to come out. So I pull out a 2. I have my I. Everything else is gone except for my 7. And that's it. So let's go ahead and try one on our own. Try one on our own. So negative 3, the square root of negative 18. Pause the video, take a second to try it out, and we will come back with the correct answer. Okay, so this one's a little different because we have this coefficient in front. That really isn't going to affect what's going on inside. We're going to simplify just like we were before. So I know 18 is 9 and 2. 9 is 3 and 3. So I have a negative 3 sitting outside, a negative inside, a 3, and a 2. I have a pair of 3's, which is going to come out, and my imaginary number, which comes out. So that leaves me with a negative 3 in front. The pair of 3's that I pulled out, my imaginary number. So the only thing left inside is the square root of 2. And I simplify by multiplying everything together. So negative 3 times 3 is negative 9i, the square root of 2. And hopefully that is the answer you got when you checked on your own. This is what we can call number 3. So it's okay to have negatives outside, and it's even okay to have negatives with imaginary numbers. We're not trying to get rid of every negative number. We're just getting rid of the negative numbers inside of our radical. That is the problem. A negative number outside isn't a problem. That's fine. Alright, so then So far we've only been dealing with what happens when we take square roots. What happens with our nth roots? So let's think about, for example, the third root of -8. We can type this in our calculator and it gives us an answer. It doesn't give us an error. Well, what if I do the fourth root of -16? Here I get an error. What about the fifth root of -32? This gives me an answer. I get -2. So why am I getting errors when I take the square root or when I take the fourth root, but I'm not getting an error when I take the third root or the fifth root? Because think of what happens with a third root. This means that I multiplied -2 3 times. Well, if we expand that, that's -2 times -2 times -2. What's a negative times a negative? Gives me a +4, but a +4 times a -2 gives me a -8. So I can have 3 negatives, and I end up with a negative. Here, my index of 4 is saying that my answer, whatever it would be multiplied 4 times. So -16, I know that that is close to -2 to the 4th. So that's -2 times -2 times -2 times -2. And -2 times a -2 is a +4. +4 times -2 is -8. -8 times -2 is +16. There's no way that I can multiply 4 of the same number and ever end up with a negative. So I can with 3, but with 4 I can't. And I'm sure you can already guess the pattern, that -2 to the 5th power, I'm going to have a negative, times a negative, times a negative, times a negative, times a negative, 5 negatives. 2 of them are going to cancel to be a positive, 2 of them are going to cancel to be a positive, and then I have this left over, which will give me a negative answer. So I can multiply 5 of the same number and end up with a negative. So what we're really seeing is, because a negative times a negative gives us a positive, when I have even numbers, or even indexes, then I'm going to have only positive numbers. My odd powers and my odd indexes do allow for negative numbers. That's why I'm not getting the error. So let's make that a key point. Right, a key point is that even powers, okay, or exponents, and even indices, or an even index, is going to only give positive numbers, right? So we can't take the roots of a negative, so we have to use imaginary numbers. Imaginary numbers. Right? So with even powers or an even index, that's when we use imaginary numbers. Right? In the other case, with odd powers or an odd index, right, we can get negative numbers. Can get negative numbers. So you do not need imaginary numbers. And so for odd powers and an odd index, you do not need imaginary numbers. So let's see a practice problem for this. So example number 4. If I have the third root of negative 64, and here we're going to throw in some variables, x squared and y to the fourth. We're going to simplify as always. This negative number is okay because really we're saying we're trying to find what 3 numbers multiply to give us this group, which is just saying, alright, well a negative times a negative times a negative might give us this negative 64. That's okay. So we factor it out. I know that this is 8 times 8, and I know that this is 4 times 2, and 2 times 2. This is 4 times 2, and 2 times 2. So, what number do I want to pull out? Well, if we expand everything, my third root of 2 times 2 times 2 times 2 times 2 times 2. We have 2 x's and 1, 2, 3, 4 y's. Alright, we're actually going to change this and make this negative 128, which would give us one more 2 times 2. Right? And we know that we have our negative. So here I want to find groups of 3. So I have 1, 2, 3. So I know one group of 2 is coming out. I have 1, 2, 3. I know another group is coming out. So that means I'm pulling out a negative 2. I'm pulling out a negative 2. And then here, this 2 is stuck inside. So I have a 2 inside. I don't have enough x's to take out, so I can take that away. I have 1, 2, 3, 4. So I can take 3 of these out, which leaves me with 1. And, oh, this is negative. Right? So even if these are all negative, 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 these negatives come out, these negatives come out. A negative times a negative is a positive 4. Then my y is going to come out. Do I need to take an imaginary out? No, because it's okay for me to have all of these negatives inside. And so then this negative 2 can stay inside, and that's alright. And then my x's stay inside as well. Alright, so we have a few self-check problems. Go ahead and do these in your notes. Careful that you're paying attention to the odd and even index to see whether you should be using imaginary numbers or not.